Hallo alle zusammen. Welcome to our ASP.NET Core Complete Course for Beginners Part 2. In this tutorial, we are going to talk about dependency injection containers. We'll learn built-in logging mechanism, how to configure built-in logging, how to completely replace your built-in logging to structural logging like Serilog, how to use Serilog, how to configure Serilog. We'll talk about app settings, how to configure your app settings based on your environment, why we have multiple app settings, how to work with app settings, how to store your sensitive information in your configuration. We'll learn entity framework. We are not going to completely learn entity framework. We will talk entity framework in our next lessons also, but for this tutorial we are going to configure and use entity framework through Sqlite. You will learn ORM, why we need ORM, what is the purpose of ORM, and we'll configure our application to work with Sqlite, and also we'll talk about how to configure Sqlite. It is going to be really interesting. Let's dive in. Let's talk about dependency injection in our applications. We already have two tutorials related to dependency injection. We explained dependency injection for juniors and for advanced developers. Right now, to make a complete tutorial, we need at least to understand, but if you want to dive into details of dependency injection, just check these two tutorials to learn more about dependency injection. When you construct your application, your classes may require some other classes to be instantiated first to run properly. For example, in my case, I have cards controller, and for my card controller, I'm requiring some additional services to be installed first to use inside my card controller. What I mean, let's say I have some sort of logger here, okay, and this is my third-party library log service, okay? I'm using this service for logging purpose. The problem here is inside my card controller, I have directly instantiated my third-party library log service, and I will have a big problems when I test my card controller, and also when I want to replace completely my third-party library log service with a Microsoft built-in or other type of library services. I need to open my card controller source code and directly change everything here. So you see, the problem here is we are specifying new keyword directly in our card controller. This is the biggest problem in our application. But how to deal with this problem? Is there any other possibility to deal with this problem? Let's go to our diagram here, and we have card controller and we have log service. This is what we just explained, and we want to somehow isolate our log service from card controller. And one of the popular way of isolating two services and creating a loosely coupled communication between services is, of course, creating one more additional abstraction over your service, and that's how it will look like. In my case, I have cards controller again, but it not depends from Serilog or Microsoft Log Service, depends from ILogger service interface. It helps me to specify any other concrete implementation I want. For example, if I want to change my implementation to Microsoft Log Service, I will not go to my card controller. I will not open my source code for card controller and change any line. And it is also applicable for Serilog Service because they both will implement ILogger service interface, and I will not go to card controller and change source code. This is the real purpose of using dependency injection. So let's go to our application and specify our logging mechanism. Microsoft provides special interface for us, and it is called ILogger interface, and you have ILogger generic interface. When you use a logging mechanism for your home controller, you should specify ILogger home controller. I'm using card controller, so I should specify ILogger card controller, and let's inject it. This is our injection mechanism. When you provide some service, some class from your constructor, it is going to be constructor based injection. We have three injection mechanisms. We have constructor-based injection, we have method-based injection, and we have property-based injection. And the most popular one is going to be our constructor-based injection, and in mostly in most cases, you will realize that your application uses constructor-based injection. And here I'm just using constructor-based injection for my ILogger. Let's run our application. I haven't dealt with dependency injection yet. I haven't configured anything for my dependency injection, but somehow everything is working. Let's navigate to our cart controller and see if everything is working or not. So you see, everything is working. Now, let's try to understand why it is working. Let's go to our program CS. In our program CS, we have create builder. This create builder in its internal implementation already injects ILogger interface with additional implementations. It has debugger-based implementation for debug window, and we have injection for our console application window. So you see, when you run your application logging mechanism, you are getting log information for your console and for your Visual Studio's debug window. That's how it is automatically configured from the ASP.NET Core perspective. Of course, it is possible for us to change it, and we'll talk about it also. Right now in our create builder, we have the exact implementation for ILogger, but how about not injected services? For example, let's create a folder here. Let's call it services folder. And for my services folder, I will add one interface called iNotification service. iNotification service. Great. This is going to be a marker-based interface. It doesn't matter for us. The purpose here is to understand the injection process. I'm going to specify iNotification service. Great. I have iNotification service. Let's just use it. Let me just also create a private read-only field for it. iNotification service, notification service, and let's specify notification service, like notification service, and let's change our logger mechanism here also. For ILogger, we already mentioned that we have this interface implementation, our dependency injection, as a built-in functionality, but we don't have iNotification service because this is my third-party implementation. This is user-based implementation, and for ASP.NET Core, we don't have any information about iNotification service. But let's run our application. When you run your application, your framework will try to construct your cart controller. From the framework perspective, the responsibility of instantiating of your controller is in framework. So let's just go to the carts, and here we are getting the exception about iNotification service. It means when your framework tries to instantiate your cart controller, it's checking that do we have any dependencies or not. If we have, it will check from the dependency injection container if we have any dependency or not. Let me show you how it looks like. This is our framework. The responsibility of this framework is instantiate your cart controller and call your exact method. But when we instantiate our cart controller, we have two dependencies for ILogger and for iNotification service. Our framework will reach out to dependency injection container. This is, let's say, a sub-application inside our ASP.NET Core. The responsibility of dependency injection container is to deal with dependencies. What is a dependency? In my case, our ILogger is a dependency. iNotification service is a dependency service, okay? And you should have this information in your dependency injection container to deal with this injection problems. In my case, I have information about ILogger in my dependency injection. So first one is resolved. But right now, I don't have any information about iNotification service. It means when we reach out to dependency injection container and check if we have the information about iNotification service, this will return something wrong, and this framework will fail to instantiate our application, our exact controller. That's why you need to specify all your services in your dependency injection. Let's go to our program CS, and before building our builder, you should specify builder services add. And in my case, I have add transient for transient services, add scoped for scoped services, and add singleton for singleton services. If you want to learn more about a transient, scoped, singleton, just check my dependency injection deep dive tutorial to learn more. And right now I will use a transient and I will specify a notification service here. But that's not all, because you should specify the exact instance for your iNotification service. There is no possibility for us to instantiate iNotification service, and it doesn't tell anything for your dependency injection container. And let's add a new implementation for our notification service, notification service. Okay, and let's inherit from iNotification service. That's all. And let's go to our application and let's specify notification service. Great. Now we have information about ILogger and iNotification service. We manually added iNotification service implementation to our dependency injection container. This is the place where dependency injection container accepts information about your dependencies. And let's run our application, and we should be able to construct our cart controller without any notification service error. Let's just try to run it. One cards, and here we are able to construct our cards controller. That's how we are dealing with dependency injection. And in short, the dependency injection container is a place where where our framework reaches out to get the exact information about our dependency. Okay, and dependency injection doesn't mean that you should always work with interfaces. For example, I have notification service, so you see for my cart controller I directly have notification service as a dependency, so I am going to use the notification service. It is also okay, it doesn't matter. And let's go to our program CS, and I am just going to specify notification service. I am moving the responsibility of instantiating notification service class to my dependency injection. It is also applicable because every class by its nature is abstraction. So if you have more than one implementation for the given interface, you should create your interfaces. Otherwise, using the direct classes is also okay from the design perspective. And you see, that's how we are dealing with this problem, and everything is working. Now let's back to our logging mechanism, and we learned that we have the built-in iLogging mechanism for our application, but we are able to easily change our logging behavior. Right now, when I want to log my information, I'm just going to specify logger, log information, and retrieving data from, let's say, name of get card with account ID and card ID with the given card ID. And let's just format it a bit, and let's specify our name of, and here we are. Let's just run our application and see where we are writing this log information. So you see, when you run your Visual Studio, we have debug window here. Let me just open it. So we have debug window, and let's go to our one cards one. Let's hit enter, and let's open our console window. So retrieving data from get card with account ID 1, card ID 1, and let's open our Visual Studio, and we are getting information about retrieving data, the same information in our debug and in our console window. Why it is like that? Because we have the already built-in create builder functionality, and this create builder has multiple providers. Okay, what is a provider? For example, when you write information to debug is going to be one of your provider. And for example, when you write information to console, it is also another provider for you. When you write it to file, when you write it to third-party service, they are going to be different providers for you. And you are able to completely modify, to completely change these providers. How? Of course, using builder logging.clear providers. Let's just run our application. In this case, we don't have any provider. It means I have removed writing functionality for debug, for console. Everything is working, but there is no implementation for the concrete writing. So you see, we don't have any implementation for internals of our logging process. And you're able to specify builder logging.add console. For example, at console means I want to write log information only to my console window, and it will not use debug, but will use the console only. Let's run and let's navigate to one cards. Okay, and let's use one here. And here we are retrieving information. Let's go to Visual Studio, and in our Visual Studio, we don't see this information because we have only one logging mechanism, and it is our console. And if you want to write a better information, you can use add debug with logging add JSON console. Okay, let's just remove add console. Add JSON console is a bit interesting implementation of this provider. It is allowing us to write information using JSON format. Let's just run it, and let's go to one cards one. Let's hit enter, and here we are able to see information in a JSON format. That's also really interesting, and it is also possible for us to add additional providers, to implement additional providers for logging. But how to configure our logging? We have special file called appsettings.json. We already mentioned about it, and I will use appsettings.development.json because I'm in a development mode. I'm not using my production mode. For the production, go to appsettings.json, but for the development, use appsettings.development.json. And you see we have logging log level. For log level, we have different levels of logging. For example, let me just show you. We have critical, debug, error, information, none, trace, warning. So I will use, for example, not information, but warning. Okay, it means for all type of loggings, we are going to use warning. And this one indicates that only for Microsoft.ASP.NET Core use, let's say, information. If you want to have some sort of exception for default, you should specify the exact namespace. Let's change our Microsoft ASP.NET Core to warning also, and let's run it to make a clear understanding, to see everything in a clear manner. Let me just navigate to one, cards one, let's hit enter, let's go, and here we are able to see our information because we have specified our log warning. But when you specify log information, it will not be possible for you to see your log information because for the default we have warning. Okay, and I'm using log information, but I want to see the information based logging, information level logging for my controllers. And to make it work, you should just copy your controller namespaces, go to the appsettings.development.json, and after maybe Microsoft ASP.NET Core, specify your controller with information. It means we have, for all type of cases, we have warning, but for the learning ASP.NET Core Web API controllers, we have exception. We are using information-based logging. Let's just run it. And let's first check our cart controller. In our cart controller, we should have the log information. So you see we have log information, and let's go to one, cards two, let's hit enter, let's open our application console window, and here we are able to see our log information. As you might guess, people not always prefer to use built-in Microsoft logging mechanism. We have a lot of different approaches for logging information, and one of them is going to be our structured logging. We'll learn structured logging. We'll learn how to replace our built-in logging mechanism with structured logging using Serilog. But let's first try to understand what is structured logging. Structured logging is a special form of logging which helps you to interact with your log information as a data set, to query and to retrieve statistics you want. We'll use Serilog, so let's go to Tools, NuGet Package Manager, and type install package Serilog ASP.NET Core. Okay, let's hit enter, and here we are. Let's go to the packages, and we have Serilog.ASP.NET Core. In this case, this is a library that consists from other libraries. So you see we have other dependencies like Serilog, sync file, debug, console. They are acts like a providers in our logging mechanism. So we have file as a provider, debug, console, and they are calling them as syncs. Okay, cool. Now we have different ways of configuring our Serilog. Let me show you. This is our Serilog, and we have hard-coded Serilog configuration directly in our application, directly in our program CS, and also we have configuration-based configuring our Serilog. We'll learn both. So let's start from hard coding. This is the easiest one of configuring our Serilog. So I'm going to remove these clear providers, etc., related to built-in functionality. And I want to build our logger. New, let's type the new logger configuration from the Serilog. Okay, that minimal level is going to be our information. At least we want to start logging from the information level. Okay, and I want to write to console and plus write to file, and I want to specify logs my log file.txt with a rolling interval to rolling interval day. It means I want to generate my log file hyphen we will have a special unique ID from the Serilog perspective. So I am making it just empty here, and I am providing configuration to Serilog to create this log file per day. Okay, and let's create our logger. Now for the builder, we have host, and let's use Serilog. And let's specify our logger. That's all. Let's run our application and see if Serilog is working or not. You will see from the interface that it is working or not. Okay, let's open our console application, and here we are. So you see, this is our Serilog. So you see, it has different colors here. It means we are using completely different logging mechanism. So let's go to the Part2, hit enter, and see if injecting log is working or not. Okay, so here we are. We have information here. All the information we want, we have here. Great. So you see, we have action get card, controller information. We have more information rather than built-in Microsoft Logger. And if you want to log your requests, also you may specify special middleware called use Serilog request building, and when you run your application, it will log all your requests. That's also really good functionality from the Serilog. Let's see. Let's run our application, and here we are. So you see, we have all the request information, endpoint information, etc., related to our request. Great. We have the built-in hard-coded implementation for our Serilog, and let's go to our logs folder, and you see in our logs folder we have my log file and the generated date time, and let's open it, and here we are. This is our logged information. Great. So let's find our log information here. So you see we have retrieving data from get card with account ID and card ID. This is our simple formatted information. Of course, this is not a best way of implementing Serilog. Why? Because we are directly typing everything here in our application, in our program CS. It would be better to move this configuration outside to our app settings, and also to have better formatting for our log information, because this is not a best structural way of implementing our log. For that reason, I am going to remove our logger from here, and let's use our Serilog with additional overload version. So you see we have action host builder context logger configuration. So let's provide our context with configuration. And I am planning, let's just simply do it in this way. Okay, like this. And let's call configuration read from context configuration. It means we are planning to read our information from configuration. Read from configuration. Okay, we are planning to read information from the configuration. That's why we need to go to our appsettings.json, because right now I'm working in a development mode and I want to completely replace this log information with Serilog. So in our Serilog, we have tons of configuration for our application. Let me just show you how to configure them. This is how it will look like when you use your Serilog. For the Serilog, we have two logging providers. I will use console and I will use file configuration. We have specified minimal level. So in hard-coded version, you are doing everything in a building mechanism. But in this case, you are typing everything to your configuration. You are adding everything to your configuration. So in my case, I'm using Serilog. Serilog will use two things, that two providers. In our case, it is console and file, and we have minimal level to the information. We have write to information, so this write to is going to use our sync information. So you see first is going to be our console, so Serilog syncs console. The write to, let's write to our console, and for the file, we are specifying our name to file, and for the arguments, I'm specifying my log and file. So right now in our application, we have my log file, but we are planning to have file hyphen with unique ID txt, and rolling interval is day. And the most important stuff here is we are going to use compact JSON formatter, and you also able to use different type of formatter, but right now I will just use compact JSON formatter to have least space in our log files. Without it, you will get just simply string information. And I am also providing for my Serilog to get information for log context from log context with machine name. There is no need for you to completely provide all enriched information, and that's why you just need to, or even you can just bypass these lines, and there is no need to specify the enriched stuff. And let me just run our application, see if everything is working. And let's open our application. So you see our application is working. 1 cards, 2, let's hit enter, and here we are able to retrieve our data. Now let's go to our log files. I have file. Let's open our file and let's type retrieving. So you see we have retrieving information, and this is not just a simple string. We have really good data here to investigate, to search, and to get statistics based on our log information. So you see we have action ID, we have action name, and we have request ID, we have request path, all the required information to investigate the issue, to learn more about request you have in your log files. But that's also not all. Why? Because in our case, we should specify the proper logging mechanism. So you see, I haven't touched any information in my application in my cart controller, but it was really easy for me to easily change the Microsoft-based logging mechanism to Serilog. I didn't change any line in my carts controller. Of course, in your carts controller, you should just specify a proper formatting. So I'm just going to specify something like this. Let me just remove this one. For the Serilog, you should specify at, it is going to be action name, okay, with account ID and with and card ID. It should start with at, and let's specify the exact information, name of get card, okay, our account ID and our card ID. Great. Let me just remove our file information. I'm able even to completely remove this file from here. So let's run and see. This is not a built-in C# behavior when you specify string formatting. The Serilog will use this type of log formatting for better searching. Okay, let's just navigate to cards 1, hit enter, and let's go to our application. Let's stop it and go to our application, and we have this data here. Great. So you see, we have action name, account ID, card ID, but we have more detailed information about our logs. So you are able to search for your action name, account ID, card ID to easily find. So you see, this is our card ID 1, account ID 1, and action name is get card. So it is something like specifying your exact data by variable. This acts like a variable. So you have action name as a variable. This variable's value is get card. For account ID, this value is 1. For card ID, it is value also is 1. That's how we are dealing with Serilog. So it is always better to move Serilog configuration to outside, and you don't need to completely write everything line by line manually. I will share this code with you, and you will be able just copy and paste to your projects. To make our learning process more interactive and more practical, let's imagine that we need one more service to use in our account controller, and it is going to be our transaction service. Transaction service requires two parameters to be used, one for the URL of transaction service, the other one is a secret key to call our transaction service functionalities. Okay, and what I'm going to do, I'm also going to explain how we are configuring our application in appsettings.json file. We'll try to understand how to configure our different environment-based configuration and how to differentiate production-based and test-based configurations. That's why let's first create our transaction service. Right now in our services, we have our notification service and notification service. And I'm going to add new class, which is going to be our transaction service. Transaction service. Okay. This is our transaction service, and our transaction service requires two parameters. The first one is going to be private read only string our URL and private read only string key. And let's specify these two parameters. So our transaction service requires URL and key to work properly. That's why we need somewhere to store this information and provide this information from our upper layer. The upper layer is going to be our account controller. Okay, let's just inject our transaction service here. This is private read-only transaction service and transaction service call service, and let's just inject it transaction service, and let's assign it like this. Great. Now we have transaction service. You may be asked that why we haven't specified a special interface for transaction service. Of course, it is up to you to specify interface or not. But for me, right now we have only one simple implementation, and we don't have the future-based differentiation between transactions. So I will always use one transaction service, and if I require some changes, I will do it directly in transaction service. So that's why it is completely okay injecting class to your services. Don't try to always level up this class to interface level and use interfaces, okay? Because interfaces are really complex in most cases. They are adding additional complexities to your application. Let's go to our program CS because we have dependency injection, but we haven't configured it yet. So I'm going to specify builder services add transient, and it is going to be my transaction service. But it is again completely okay for you to specify iTransaction service and depend from my transaction service. It is some cases better because if you are testing stuff, it would be completely okay to use interfaces. In my case, we have transaction service. We have configured our dependency injection. Now everything is working. And for the transaction service, I have two properties, okay? I have string key and string URL information. When I construct my transaction service, I should specify these properties. First, I will show you the really simple implementation of transaction service, and that's why there is no need for you to provide these two information, and just simply providing configuration from Microsoft will be enough. Okay, cool. Let's specify them. And sorry, I just removed them. Private read-only string URL and private read-only our key. Okay, this is our key. And what I'm going to do, I'm going to specify this key and URL information first. In my configuration, I will add additional configuration for transaction service. Transaction service. This is my transaction service. Transaction service. Great. So this app settings file allows you to specify the hierarchy depending from your application requirements. So it is up to you to configure this section of configuration. In my case, I will specify the root element for my transaction, which is going to be transaction service, and I will have the URL information. URL, let's say https, I don't know, www blah 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 blah.com version 1, and this one. And for the key, let's specify some random key here. Okay, that's good. Now we have configuration, but as you see, I have specified my configuration in appsettings.development.json. Why? Because in my launch settings, I have here special profile called HTTPS. If you want to learn more about profiles, just check our first part of this tutorial to learn more. Right now we are using HTTPS. Let's find our HTTPS profile. And for HTTPS profile, we have ASP.NET Core environment, and it is our development. It means our application, our framework will try to read configuration first from appsettings.environment name, which is going to be development.json. So the preferable file here is appsettings.development.json. So let's go to our ASP.NET Core source code from the GitHub. And in this GitHub, you see we have special class called web host. Let me do a little bit zoom here. And in our web host, we have special configuration, configure app configuration. And you see we are reading these app settings information automatically. So we are reading appsettings.json and we are reading appsettings.environment-based.json. So that this environment name will take information from the launch settings, and it will read ASP.NET environment. That's why the preferable configuration for us for development is going to be appsettings.development.json. If you changed it to production, it will be appsettings.production.json. Okay, cool. Now let's switch to our application. And in my application, I have dependency from my configuration. And let me just read information from our configuration. And we have multiple ways of injecting configuration. The preferable way is to use options pattern, but right now we are just trying to somehow learn the configuration stuff, so it is completely okay to use the configuration like this. So let me specify our full path for the configuration. This is going to be our transaction, and let's take the URL. Okay. So our configuration is case insensitive. So that's completely okay to provide transaction service URL like this. Cool. And now let's specify our key. I'm just going to copy this stuff and change our key to key. Great. Now I have account controller with transaction service, and let me just check if the transaction service can be constructed or not. So I'm adding the breakpoint here. Let's run our application. And here we are. So let's check our URL. So you see we are able to read our configuration, and for the key it is also okay. And this is not the only way of reading configuration. There are multiple ways of reading them. So for example, the first one is going to be the get section. So in this get section, you are specifying your section like this. And for the key, you will specify URL something like that. And the third one is to access to all these elements using get section. Okay, just specify get section for the transaction, and let's dot again get section to the key. Great. So you see we have at least 3 ways of reading this configuration information. So this is get configuration, get section dot value. Great. Now I'm just running my application and trying to see if everything is working or not. Let's check one by one. So URL, so you see we have URL information, and the key, we have key information. That's how we are dealing with the configuration. And great, now let me just replace our app settings development, our development environment to the production environment. So I'm going to app settings JSON file, launch settings JSON file. Let's go to the profile HTTPS. Right now, currently I'm using HTTPS as my main profile, and I'm changing it to the production. Okay, let's just run our application again. Right now, we have the configuration only in our app settings development JSON, but I have changed my environment. It means the application will try to read app settings and appsettings.production.json. And let's see, it should return null values. Let's go to the transaction service. And here we are, key is null and URL is null. Great. Let me just create another app settings file, right click, add new item. And from the ASP.NET Core, let's search for settings. And let's find our app settings file and appsettings.production.json, because we have the production environment as an active environment. Great. Let me just copy the data from transaction, from development to production. Let's paste it. So this is going to be production and prod key. Cool. And let's run it. We have added our breakpoint. So you see key is prod and URL is production URL. That's how we are differentiating from different environments. So we have production environment, we have development environment. You will always specify different key values for your services per environment. So per production, you will have different configurations. For testing purpose, for the development, you will have completely different configurations. So far, we talked about in-memory data structure, and we implemented all our endpoints using this type of data storage. Unfortunately, this is not a relevant data storage for us to store information for production purpose. That's why we are going to talk about Entity Framework Core. Entity Framework Core is Object Relational Mapper. What is Object Relational Mapper? Object Relational Mapper is a special language provided mechanism over your SQL. It means there is no need for you to completely learn, to completely understand SQL to interact with SQL. Okay, so in SQL we have database, and per database we have as many tables we want, and to interact with tables, to store information to these tables, we need to write pure SQL commands. Of course, not all C# developers know about SQL, and using ORM there is of course no need to completely learn all SQL commands, and ORM helps you to wrap your SQL commands, to add additional wrapper over your SQL commands, and make your life really easy to not interact, at least interact with a minimum with your databases. Okay, so in a classical C#, there was adonet, active data objects, adonet, and for adonet we had the connected model, disconnected model, and the last one was entity framework. Working with entity framework, of course, in most cases entity framework also provides the way directly writing SQL commands, but at least to do some basic stuff there is no need to provide SQL commands, and you can interact with your database like you are interacting with your in-memory data structures like arrays, lists, and etc. Okay. And the Entity Framework Core allows you to interact with different providers. So just learning one Entity Framework Core, you can easily work with SQL Server, Sqlite, PostgreSQL, MySQL, and other type of data providers. So you can find the list of data providers from this link. And as you can see, we have SQL Server, Sqlite, in-memory, Cosmos, PostgreSQL, MySQL, and etc. So it provides almost all type of working with all type of databases for modern day. So Entity Framework Core is going to be wrapper over your all type of SQLs, and it provides a really easy way of interacting with your database like you are interacting with in-memory lists and arrays. Okay. And for Entity Framework Core, we have approximately this type of mechanism. So instead of writing, for example, select ID name from mydb.cards, the mydb is going to be our database. You are specifying your database as database context. And for this context, we have cards list, let's say. And from the card list, you are selecting ID and name. This is a special language. So you see, this language is going to be a wrapper over this language. So when you specify this command, our Entity Framework will convert this command to the exact SQL command and provide it to your database, because your database doesn't know this language. Your database directly works with SQL commands. And now it is time for us to implement our Entity Framework and completely remove our current account DB context. That's why first we need to start our development process using our entities. Let's right click, add folder, and it is going to be entities. And for the entities, what we are going to do from the models, I'm just going to copy my account. Let's first just copy our account here, and let's go to entities, right click, add class, and it is going to be my account entity. Okay, and let's paste our account entity. Now we have ID, we have number, name, account type, and list. The list is going to be the same as we specified for our in-memory database. And for the ID, if you are not specifying direct name of ID or class name ID, something like this, account ID, our Entity Framework will not generate a specific key for us. That's why it is always preferable to specify the key attribute. So it is in system component model data annotation. So it means for every table we have primary key, and that's how we are providing this primary key. And also for database generated, you may specify database generated options identity. It is also the conventional way of providing the ID for ID and account ID. It means there is no need to provide this key if you are providing ID or account ID for your key field. Okay, so that's completely okay if you are not specifying, but to differentiate between your DTOs and your data models, it is preferable to configure these attributes in your entities, or you can configure it from the Entity Framework Core itself. So for the name, I am going to specify that my name is required, and the name max length is going to be 40. And for the number, let's specify that our number is required, and for the number we have max length, which is going to be 20. Okay, and for the account type, let's just copy our account type also. This is my simple account type, and we'll see the difference between the enums and it is storing mechanism in our database. But for now, let's just completely use it as is. And let's go to our, right now we are able to completely remove our account. I'm just going to remove our account, and let's just copy our card here. Okay. Let's just copy and right click, add class, and call it card. Hit enter, and here we are. Let's paste it. So for our ID, let's just specify our key and database generated options identity. And for the holder name, it is of course required, and it is going to be max length equal to 50. I think the 30 will be enough. For the expiry date, it is of course required, and for the expiry date, let's specify our length like string length, which maximum length is going to be 5, and the minimum length is also 5, because we are specifying something like this, 0327, and we have 5 symbols here. And for the number, let's specify our required, and the number is going to be the string length, which is, for instance, we have something like this: 444, 555, 333, 6767. So we have 4, 16, 19 symbols, and let's specify the maximum length 19, and the minimum is also 19. That's how we are specifying a special rule for our card information. Of course, we may use the card and account information. So actually, there is no need to remove your account and card information. But right now, we'll just interact with our account and card entities. So it is completely okay for you to delete, or it is up to you to store this account information in models also. So I'm just going to the copy our entity, right click, add class. Let's just restore our account information. Okay, and let's just remove this keys, because for your DTOs and for your entity models, you have a completely different mechanism. So you see, we are not specifying these attributes, because these attributes will help us to generate special rules for our database. Okay, we'll see it together. For now, I think that should be enough for us. And what we are going to do, we need to specify our DB context to interact with our database. So right now we have account. This is going to be our accounts table, and this card is going to be your cards table. And we need right click, add a folder, DB context, let's say, and right click, add class, and it's going to be my DB context. Okay, let's call it my DB context. And my DB context will inherit from DB context. This DB context is Microsoft provided DB context. So I'm just going to be rename it to DB to not have conflicts. So DB context, we need to inherit from DB context to properly use entity framework. Right now we don't have entity framework, so entity framework is a special library we need to install. Let me just install it. So tools, NuGet package manager, and let's just install entity framework core. Install package Microsoft Entity Framework Core, and we're going to use Sqlite. Okay, I will use Sqlite. I think that should be okay. Let's just try again. So it is Microsoft Entity Framework Core Sqlite. Let's hit enter, and here we are. Right now, the system is going to install our Sqlite as a separate package. So let's go to the dependencies, packages, and now we have Microsoft Entity Framework or Sqlite. And let's just try to continue our development process. So I'm just going to use Microsoft Entity Framework Core. So you see, this is in Microsoft Entity Framework Core namespace. And let's provide our DB sets. That this DB set is going to be a table indication. Okay, in this case we are specifying that we have set of, for example, card information. Okay, set of card information and cards, and of course we have DB set And this is our account. Great. Account information. Cool. And what we need to do, we need to somehow construct our DB context to get connection string information and connect to the database. That's why we have special extensions. Of course, we have multiple ways of configuring. So, for example, we have special override methods here. For example, on configuring, you can configure your entity framework Sqlite connection string from here, but for me the best preferable stuff is of course to use DB context options. So you need to create a constructor that accepts one argument and is going to be a generic DB context, which you should specify your DB context name as an options, and you should refer to the base constructor, and that's simple all. There is no need to add additional stuff to this one. And so you see we have DB context options, of course, DB context options. Great. And that's all. That's all from the DB context configuration. So we are specifying our database. Okay, this is our database. And for the given database, I'm specifying that we will have two tables, one for cards table, the other one for accounts table. And for the accounts table, we will have these properties as a column, as columns. And for the card, we will have these fields as columns. So that's completely okay. That's how we are mapping SQL structure to object relational mapper structure. Great. Now we need to configure our DB context. Let's go to our program CS. In our program CS, we need to specify something like this. From the services, we should specify our DB context service. So builder services add DB context. So you see, add DB context is able to add any type of entity framework DB context. So depending from your MySQL, Transact SQL, Sqlite, you will not change this functionality because the entity framework core is a higher abstraction over your SQL variations, over your SQL dialect. So configuring it one time will be completely enough for you to internally change your databases. So you can easily change your database from SQL Server to Sqlite, from Sqlite to MySQL, and etc. Okay, and at DB context, we should specify our DB context. It is going to be my account DB context. Okay, great. And let's just provide use Sqlite. So this is our extension method. For SQL Server, we have use SQL Server, etc. So depending from your provider, you will just change this extension method, and that's all. So we need to specify data source here, data source, and this is going to be, let's say, my Sqlite DB. I'm just providing something like this. Of course, it is always better not to specify configuration directly in your use SQL or other related provider-based extensions. We'll use our configuration, but for now, just learning purpose, it should be enough. And let's see what we have here. The only thing here is the MyDB context is not so. It would be better for me to completely remove this data folder, okay, and to use my DB context here. The my DB context, because your DB context should inherit from DB context. That's pretty much all. That's how we are configuring our database stuff. And we need, of course, to just simply go to our controllers. Right now in our controllers, we have, for example, we are interacting with this type of stuff. So I'm just going to, for now, comment them. Cool. And let's go to the cards controller also. For the cards controller, we are using our special in-memory data structure. That's why I need to comment them also. And after integrating our entity framework, we'll completely modify our endpoints. Great. Now we have our DB context. Let's just build, rebuild, and see if everything is working or not. So we have two issues here. Let's go for it. Let's remove unused namespaces like this, and this one also. Great. Now let's build, rebuild, and that should be okay. Cool. Now everything is working. What we just need to do, let's see if everything is properly working or not. For that reason, we need to migrate our database first to see if we are able to create our database. Right now, we don't have anything in our database structure. We don't have any database. We don't have any tables. But we have specified that we should have two tables with one database called MySQLite DB. So let's just use it. So I'm going to Tools, NuGet Package Manager Console, and first you need to specify migration. What is a migration? Migration is, for example, let me explain it in an easy way. So we have our code from the C# perspective. So we have specified that, okay, I will have one DB context. Under this DB context, I will have two tables. But right now, in a physical manner, this is our physical layer. In a physical manner, we don't have this implementation. So I should somehow specify that, okay, let's go to create a database using my current DB context and create tables that I have in my DB context. And that's why we need to provide migration command to physically create these tables. Okay, cool. Now let's do it. For the physical implementation, we need to specify a special library to special package to provide migration tools. First migration tool is going to be add migration initial DB. So add migration is our first command, and for the given command I should specify some name. So to indicate that I'm creating this table for the first time, I'm specifying initial DB. So you can use any name you want, but the first command should be add migration. And let's hit enter. Will fail because we don't have add migration as a special command for our Visual Studio, for our application. That's why you need first to install Entity Framework Core Tools. So install package Microsoft Entity Framework Core.tools. These tools will allow you to run such commands like update database, add migration, and etc. So let's just try to run add migration again. I'm hitting enter and let's wait. And it should generate our migrations folder with additional configurations. So you see, right now I have migration structure. And you see we have the special folder right now in our application. The add migration command created these migrations. And in our migrations, we have snapshot and initial DB. So let's see one by one what we have in our initial DB. What is initial DB? Initial DB is a special way of migrating data from your ORM to the physical database. So it is just a special language which describes what you will get at the end of the running the query. Okay, right now it's specified that we'll create a table called accounts table, and the account table will have the following fields with the given properties. For example, ID is going to be an integer type, and it will use auto increment for it. For the text, for the name, we'll use text. For the number, we'll use text with max limit, and for the account type, it will use special integer. So we have also primary key. That's why we specified our keys attribute. Cool. Now we have all the description. So it is always better to check your description because you may forget to add some annotations, etc. First, you need to be sure that everything is okay. When we run this command, for now we don't have tables. We need to run this command. So first step is generating this migration based on your DB context. So what Entity Framework did in this case, Entity Framework just got our DB context, and from DB context, it detects that we need to create two tables with the following properties for the given data structure, and it provides a first skeleton, a special language, intermediate language for us. And to run this command, we need to specify one more CLI command. Let's do it. Update database. And let's hit enter. Let's wait. So you see all the commands have already been generated. So you see you can just simply copy this command and run in your Sqlite application and it will work. So now we have our tables. Let's go for it. in our application structure. So you see, this is our learning is .NET Core Web API, and under that we have my SQLite DB. So this is our MySQLite DB. Oops, the only thing I forgot to add, it is our extension. So right now I have my SQLite DB in our program says it should be MySQLite DB because the extension for our application right now we have a file but without extension. Let's just simply delete it. Okay, let's go tools, NuGet package manager console, and go to the same command again and hit enter. And let's wait, and here we are. This is our MySQLite DB.db. Cool. Now we need to somehow open this file to see what we have inside this DB. That's why we are able to use different third-party applications. But for me, the easiest way to interact with DB, to interact with SQLite, to use special extension from Visual Studio. And you see the third one here is SQLite and SQL Server Compact Toolbox. Let's use it. Let's download it and let's wait. This is special extension which allows us to interact with SQLite mostly. So let's just close our application. You need to close your Visual Studio also and restart it. After installation, just go to the tools and we have SQLite, SQL Server Compact Toolbox, and let's go for it. And you see we have all the data type stuff here, and let's just connect. So by default, it will check our application and will detect MySQLite DB.db. So you see this is our DB, and let's go for it. We have tables, and let's see inside the tables we have cards table. So you see we have ID, holder name, expired, etc., and we have accounts information. And also we have entity framework migration history. And let's first try to understand what is migration history. Right now we have only one line in our migration history, and we have empty tables for accounts and for the cards. Let's try to understand the migration history. The migration history is a special way of checking your migration status. So right now in our application, we did only one migration. As you remember, we created only one migration called initial DB, and that's why Entity Framework created only one row with the given generation time that concatenated with initial DB, our generated migration name. And when you specify one more migration, it will just track your migrations to not to generate every time the same SQL command to migrate to your database. Let me show you it in a real world example. So I'm going to change our card information right now. Let's open our entities, and you see we have expiry date. It is string. So I'm going to replace our required string with integer expiry date. Okay, and now when I go to tools, NuGet package manager console, I'm going to specify add migration, and we change it our expiry date change it to integer, and let's hit enter. It should generate a new migration file. So you see this is our migration file, and this migration file indicates that we are going to update our column to be integer, and when we do undo operation, it should roll back from integer to string. And that's why we have these two rows. And let's go to tools, NuGet package manager console again, and just update database, and let's hit enter. And this update will happen because we don't have any information yet in our database. And let's go to our migration database, and here we are. We have two rows, and when you specify again the update database, it will say that everything is up to date, no migrations were applied. How it detects? Of course, using Entity Framework history. Don't work with this Entity Framework migrations history. This is internal table for checking Entity Framework to match our migrations, and that's why it is always better to interact only with your concrete tables rather than changing the migration stuff. Okay, and when I do the undo operation, let me just go to the expiry again. Let's make it required. I am providing the string length, which is going to be maximum 5, minimum also 5, and from integer to string, let's just call our command add migration, change it to string, and hit enter. It should do undo operation and help us to restore. So you see, this is our cards. We are going to change it to text, and otherwise it will do rollback to integer. Let me just run update database again, and migration applied. Let's go to the entity framework migrations history, and here we are. This is our 3 migration rows, and this migration rows matches with this migration. So you see, this is the given name and this name. For this name, we are just inserting these names to our entity framework migrations history. It is automatically done when you run your commands. That's how entity framework deal with migration commands. Great. Now everything is ready. Let's move forward. Now what we are going to do, of course, we have one issue here. This is our data source. For the data source, we have specified our data source directly in our application, and we already learned about configuration. It is always better to move it to the configuration, okay? But for the configuration, if we have some sensitive information, it is not always better to move this sensitive information. It is really bad practice to move your sensitive information to app settings. We'll use environment variables to store our information, okay? So what I'm going to do, first, let's store this information in our app settings. I'm going to cut this information and go to the, right now we have, let's go to our launch settings to detect which environment we are using. We have production environment. Let's change it to development. And let's go to app settings development, and let's specify our connection string here. So you see, we have a connection string. Let me just completely remove this connection string. You are able to use this connection string or specify your own connection strings. I'm going to Sqlite, specify Sqlite source, and this is my source, okay? And let's go to program CS, and from the program CS, I will specify that I'm planning to read information from my configuration. That's why I'm going to use builder.configuration, and from the configuration, let's go to the configuration itself, Sqlite source. So let's specify Sqlite source. Great. So you see, we have forgot to add a really simple symbol here. Okay, let's run it again. Great. And now you can specify builder configuration Sqlite directly. Let's just copy this line from here and let's paste it to our immediate window, and let's hit enter, and here we are. This is our response. So if you don't see the immediate window when you debug your application, just go to the debug window and immediate window. Let's just select the immediate, and that's all. You can easily copy the exact debugging value, exact debugging key, and check if you have the exact value for the given key or not. That's how we are reading our configuration information for our Sqlite. But as I mentioned, this is not a good way of storing information for your sensitive data. If you have such type of sensitive information, it is always better, it is preferable to store it in your environment variables. That's why we need to go to environment variables in your Windows operating system. Let's go to environment variables, and from environment variables, let's select the user variables, and we have system variables. Let's go to the system variables and let's add a new variable. My variable is going to be Sqlite source. Okay, and I want to specify the exact value. Let me just copy it from here, and let's go to our environment variable, paste it here, let's hit OK, and OK. Now we need to restart our Visual Studio. We may need to restart it, and then everything will work. I'm just going to remove this one, and let's just add it, and let's just restart our Visual Studio. Cool. Now let's go to our environment. So you say in our launch settings, I'm going to our HTTPS, we have development environment. I'm going to the app settings development. So you see, I don't have any information about my settings, and also in our app settings, we don't have information. So our application will not use production, but will use development. So we don't have any information about our application for our Sqlite configuration. Let's go to our program CS. For the program CS, what I'm going to do, I'm going to specify the source. Let's just change our exact name. So it is Sqlite, and we don't have case insensitive mechanism. And let's open our environment variable again to see if everything is correctly provided. Environment variable. Okay, let me just close this window. Let's go to environment variables, and from the environment variables, we have Sqlite source. So we have Sqlite source. Great. Let me just copy this to check if everything is valid for the immediate window. Let's just run it. And let's paste it, hit enter, and here we are. We have data source and MySQL db.db. That's how we are storing our information in our environment variables. This is a more secure way of storing information rather than storing sensitive information in your app settings. Let's talk about data seeding. What is a data seed? Data seed is a special process when you need some data to be your database before running your application. So right now for our accounts and for our cards, we don't have any information, and we need to do some data seeding to run our application. It is completely okay to run your application with empty tables, but right now I'm going to test some data, and you may need some additional configuration information. For example, for your enums, I don't know, for your administrator, moderators, you need some initial information for your application to be runnable, and that's why you need to do data seeding. To make your application to have a data seed functionality, you should go to DB context, and right now we have inherited my DB context, and we have special method called onModelCreating. Okay, and for onModelCreating, we are going to add our initial seed information. So I'm going to use my model builder. Okay, this is my model builder, and for model builder we have entity, and for the entity, first we are going to fill our account information, and for the account information we should specify has data. The system will check if we have the given data or not. If data exists, the system will bypass it, otherwise it will automatically create it. Right now for the card information, I am going to add some navigational property. Right now you see in our cards we have account ID, but we haven't specified our account information in our entity, so I am going to provide it. Public account. This is my navigational property. I want to navigate from card to account. Right now we have ability to navigate from account to card. So you see in our accounts we have card information, but in our card we don't have account information. That's why I'm going to add this navigational property with public integer account ID. That's going to match with account ID in our cards table. This is just for us to navigate to account information. Of course, that's completely okay for you to not to have it if you are not going to use it in your code, because you see in our database we already have account ID, but to navigate to get this account ID to do additional operations, we need this account ID information. Cool. And let's go to our DB context, and in onModelCreating, I am going to add this information. So I have one account and one card information. This is my account ID. I am manually providing it. And let's add one more card. I think it will be good to have one more card. And there is going to be ID 2 for the account ID 1. And let's change it 03 and 0320. 5 and 1122. Great. And let's do migration tools. NuGet package manager console. Let's go to our migration and add migration base migration data. Let's hit enter. And here we are. This is our simple information. So you see, and let's just update database. Let's hit enter. And it should create our information for our database. Great. Let's close and go to our cards. And here we are. We have 2 information and we have 1 information for account. Great. Now let's adapt our controllers to work with our DB context. When you specify your DB context from add DB context extension method, so you see this is our extension method, it is automatically registers your DB context. It means there is no need for you to add builder, services, add transient, add scoped, etc. It is scoped service already, and it is registered with the configuration. Okay, that's why it is completely okay for you to call your DB context. Of course, we'll work with repository pattern, we'll add our services layer, etc. We'll do all the cool things, all the, let's say, best practices. But for now, let's try to understand if we are able to work with our entity framework. So I'm going to replace my transient transaction service to DB context, my DB context. Okay, DB context. Great. Let's just copy this, paste it here, and this is our DB context. Okay, DB context, DB context. Let's go to our endpoints. In our endpoint, we have already DB context. Let me just use our account. So we have account information. So you see, when you hit end dot, you have accounts and cards information. For the accounts, it is returning DB set. That's why I am going to use to list asynchronously. Okay, this is our special extension method from the entity framework. This helps us to asynchronously call our data. So you see, this is awaitable task list. So that's why we should specify task account. I'm not going to use automapper, etc. We'll learn how to use this stuff in our next tutorial. For now, we are just simply trying to adapt our application, trying to adapt our entity framework to our application. And simply, I'm going to use, of course, you can use the to list without async, but it is always better to use to interact with your database using async await. And let's go to our DB context here. And first or default, asynchronously, we are getting account and we will use await async. So let's see action result, and this is going to be task account. Great. And that's all from the accounts controller perspective. So you see, we have injected our DB context directly to our controller, and we have interacted with our DB context to get account information and filter account information. So you see, it was really easy for us to change our in-memory data structure to entity framework, and you don't need to do additional operation when you switch from Sqlite to Transact SQL, MySQL, etc. Let's run our application. And this is our endpoint. It should return 1 account data. So you see, this is our account data. This is how we are injecting our DB context. That's how we are working with entity framework in a simple manner.